ever get that feeling, when you're staring at just a mountain of information, like you're just drowning in a textbook or a giant report, and you just know the answer's in there somewhere.
Oh, yeah.
But actually finding it feels impossible.
Absolutely. Like trying to find, it's like the classic needle in a haystack problem.
Exactly. And it turns out that's kind of how we've been evaluating how well AI understands information too. Can it find the needle in the data haystack? Right.
Right.
But what if we want AI to do more than just kind of play this hide and seek with facts? What if we want it to actually understand the meaning behind all of that information, to really get it?
Yeah, that's the real question, isn't it? That's where this, I think, really interesting research from Google DeepMind comes in. They're really pushing the boundaries of how we evaluate AI. And they're using, of all things, Michelangelo as inspiration.
Okay, now you've got to explain that one. How does one of the greatest artists of all time, how does that relate to artificial intelligence?
So picture this, right? You got Michelangelo. He's standing in front of a giant block of marble.
Okay.
He doesn't just see a random chunk of rock, right? He sees the statue. It's trapped inside, hidden within. And he has this great quote. He said, "The sculpture is already complete within the marble block. Before I start my work, I just have to chisel away the superfluous material."
Wow.
And that's the idea that this research is using to think about AI.
So instead of just seeing if AI can, locate a specific fact in a sea of data, we need to see if it can, sculpt meaning from a sea of information.
Yeah.
Am I getting that right?
You got it. They actually call it latent structure queries, or LSQ. But it's all about evaluating if AI can reveal and understand the hidden sculpture within the data, not just find the needle.
That's such a powerful analogy, but how do you actually test something like that? I'm guessing there's no AI art class where we're handing them chisels and hunks of data.
You're right. So it's a bit more complicated than that. They designed these three, I think, really clever tests. And each one focuses on a different aspect of this long context understanding. And the really mind-blowing part is that they've designed these tests to use massive amounts of information. Like, we're talking hundreds of thousands of words. Some of them even use 1 million words.
1 million words. That's like feeding an AI the entire Lord of the Rings trilogy and then some.
Okay, I'm definitely intrigued. Walk us through it. What are these tests all about?
Okay, so the first one, they call it latent list. And the idea is, imagine you give the AI a short list, and then you give it this really long, really complex set of instructions, kind of like a computer program, you think about it, written in Python.
So kind of like a recipe, but for data.
That's a great way to put it, yeah, like a recipe for data. But here's the thing. Some of those instructions, they're designed to actually change the list, right? But then they throw in all these other instructions that are just there to confuse things. So like adding a pinch of salt when what you're really making is a cake, it's not going to ruin it, but it seems out of place.
Exactly. And so the test is, after all those instructions, can the AI still accurately describe what's on that list?
Sounds like a real mental workout for this AI. What about the second test?
All right, so the second one, this one is designed to see how well AI can understand those really long, sometimes messy conversations we all have. Like in emails, for example.
Oh, tell me about it. My inbox is a testament to that.
Right. So if someone's asking for different things, maybe they want poems, maybe they want articles, maybe they even want a recipe, and it's all on totally different topics, all mixed together. So this test, they call it multi-round co-reference resolution.
Catchy.
Yeah, it's a mouthful. Maybe it's easier to just think about it as the email chain challenge.
I like that better.
But basically, it sees if AI can find very specific responses within that whole conversation, even when there are lots of similar sounding requests.
Yeah.
It's like, find the second email about penguins, kind of specific.
That sounds incredibly difficult. I'm not even sure I could do that.
Right.
Okay, there's got to be one more. What's the final test?
Okay, so the last one, this is my personal favorite. It's called IDK, short for I don't know.
Okay.
And it's basically, they bombard the AI with tons and tons of information, right? And then they ask a question that simply cannot be answered from the information they were just given.
Oh, that's sneaky.
It is. And the thing is, this test isn't about finding the right answer. It's about seeing if the AI knows when it doesn't know the answer.
Oh, that's interesting. It's like if you were trying to solve, I don't know, a math problem, and you realize you can't do it just with the history formulas you've learned. You need something else. You need to recognize there's something else you need.
Exactly. You got it. It's all about testing the AI's ability to recognize the limits of its own knowledge, which let's be honest, it's something we could all probably use a little bit more of sometimes.
So, so we've got AI wrestling with code. We've got it deciphering conversations. We've even got it admitting when it's stumped. This is all very clever, but what did the researchers actually find? I mean, can AI handle these Michelangelo challenges?
Well, it turns out none of them were perfect Michelangelos.
Right.
Yeah, they couldn't just perfectly chisel out the meaning from any data mountain you threw at them.
So even the most advanced AI that we've got today, they can't quite get to that Michelangelo level, huh? Does that mean they all just completely failed?
No, no, not at all. Actually, they tested a bunch of these different, leading AI
Yeah.
models, sort of the ones that are really pushing the boundaries of what we thought AI could even do. And what they found is that, different AIs had different strengths. Like, some artists might be amazing painters, while others are just, sculpting prodigies. Some AIs were just much better at certain tasks than others.
So there's no one size fits all AI, at least not yet. What kind of strengths are we talking about? Like, give me some specifics.
Okay, so for example, on that latent list challenge, the one with all the Python code instructions.
Yeah, where the AI has to follow that really complex recipe for data.
Right, right. So the models that use something called generative pre-trained transformers, or GPT for short.
GPT.
Those tended to do the best. They were really good at kind of keeping track of those really subtle changes to the list, even after all those confusing instructions.
So the GPT is for the win on that one. What about the email chain challenge? Did any of the AI models kind of conquer that mountain of conversational data?
That one was really interesting. A different type of model called a Gemini. I have no idea why they choose these names.
Right.
But those really stood out. They were much better at navigating those complex conversations and zeroing in on those very specific responses, even when the requests sounded incredibly similar.
It's like they could actually understand the nuances of the conversation in a way that some of these other AI models couldn't. Really, really fascinating how these different models have their own unique skills. You mentioned earlier that there were some really interesting results, maybe even some surprising results. Anything that really made the researchers scratch their heads?
Yeah, there was one finding that was really interesting, and it involved those GPT models. Again, specifically on that IDK test.
The I don't know test, the one where AI has to like admit when it just doesn't have the answer. What happened? Did they start like spouting off random facts or something?
Well, kind of. Remember, this is the one where you feed the AI these random strings of letters just to see if it knows that the answer can't possibly be in there.
Yeah.
Well, sometimes the GPT models would start to, and this is the technical term, they would start to hallucinate.
Hold on, hallucinate. Okay, now that sounds a little unnerving. Were they like writing poetry or something?
Not quite poetry, but they did start to see these patterns, this meaning where there was none. It was as if they looked at these random letters and thought they contained some kind of, I don't know, hidden message or secret code.
So they weren't just saying, I don't know. They were just making up an answer based on, well, nothing. It's like trying to predict the lottery based on tea leaves or something.
That's a great way to put it, yeah. And of course, since there was no actual message, their answers were just completely wrong.
Wow. So even the most advanced AI can fall into that trap of seeing these connections, this meaning where there really is none, which is, I don't know, it's a little reassuring, actually. It makes them seem a little more human, wouldn't you say?
I suppose it does, in a way.
Yeah.
But it also highlights, I think, a really critical point about AI development. You see, right now, the way we train a lot of these AI models is by we feed them these massive, massive data sets of text and code. We're basically just force feeding them information, and we're hoping they're going to find all the patterns of the relationships on their own.
And they're really good at it, right? I mean, that's what makes them so powerful, that ability to process information so quickly and so accurately.
Absolutely. But there's kind of a flip side to that. And that is that sometimes they start to see patterns where there are none. Or they overgeneralize from the data they've been trained on. It's like that old saying, if all you have is a hammer, everything looks like a nail. So in this case, the AI was just so used to finding these patterns, this meaning, that it started to see them even in just random strings of letters. That's fascinating and a little bit concerning, I have to say, which I think really underscores why this whole Michelangelo approach to AI evaluation is so important. We really need to understand how to measure and evaluate these limitations, especially as we start using AI for these really complex tasks. Exactly. And that's what makes these findings so compelling, right? It's not just about, can AI find the needle in the data haystack? It's can it appreciate the entire haystack? Can it really grasp the context, the nuances, all that meaning beyond just the surface?
It really makes you step back and think, doesn't it?
It does.
We're asking AI to go so far beyond like, just crunching numbers or identifying keywords in a document. We're asking it to understand the world more like we do, right? With all of its messiness and its complexities and all those little shades of meaning that make it so challenging.
Exactly. And that's what this kind of research really gives us, is like a new set of tools to evaluate not just how much AI can process, which is, it's remarkable in itself, but how deeply it can understand all of that information.
So it's less about, testing the AI for like brute force memorization. And it's more about evaluating its ability to really think critically, to make connections, to maybe even, be a little insightful, like a master sculptor who looks at the raw material and sees the potential masterpiece hidden within.
Yeah, it's a great way to put it, yeah. It's about nurturing the AI's ability to really discern the signal from the noise.
Right.
To figure out what's actually meaningful here and what's just a random clump of data.
Which brings us to, I think, the really big question: why does any of this really matter? I mean, it's all fascinating from a research perspective, but how does this impact the average person?
Well, this is, I think, where it gets really, really exciting.
Yeah.
Because long context AI, it has the potential to just completely revolutionize so many different parts of our lives.
Right.
Think about, fields like medicine, for example.
Oh, absolutely. Where doctors are dealing with, just an overwhelming amount of information every single day, right? Research papers, patient records, clinical trial data. It just goes on and on.
Exactly. So imagine if we had AI that could, not just process all that, but sift through it all, connect the dots between, maybe seemingly totally different findings, and help doctors make faster and more accurate diagnoses.
Wow. Or even think about, the legal profession, right?
Yeah.
Where lawyers are having to, pore over just mountains of legal precedents and case files to try to figure out,
Right.
what's going to happen.
To make their case.
Exactly.
So AI could help analyze those documents so much more efficiently, identify the most relevant case law, and maybe even, help predict the outcomes of legal battles. It
Yeah.
can really transform how justice is served.
It really could. And let's not forget about our own, our own daily lives too, right? Imagine having AI that could, summarize those really long articles that we should read but never seem to have time to get to or help us navigate. Like really complex information, when we're trying to file our taxes or even, assemble a piece of furniture or even just, help us write more engaging, more nuanced stories. The possibilities here are they're kind of endless.
They really are. And while this research is, it's still early days, it really does give us this intriguing glimpse into a future where AI isn't just a tool, but it's really more like a partner, in helping us understand and navigate this increasingly complex world that we're all living in.
It's like giving Michelangelo a set of chisels and a block of marble, right?
Yeah.
We can't wait to see what masterpieces AI is going to create when it really learns to understand the world around us.
And that's a thought I'd like to leave you with today. As AI continues to evolve, what role will you play in shaping its development? And what kind of future will we create together? Okay, so everyone's talking about large language models, right? These AI systems that can write poems and translate languages, even ace some pretty tough exams.
Yeah.
But how smart are they, really? Can they think like we do, or are they just really good at mimicking human intelligence?
That's the question, isn't it?
Yeah.
And it's at the heart of this research paper we're diving into today.
Okay.
Michelangelo. Long context evaluations beyond haystacks via latent structure queries. Catchy title, right?
It's a mouthful.
It is. But it boils down to this. Most benchmarks, they test an LLM's ability to find specific facts in a massive data set, like finding a needle in a haystack.
Right. Which is impressive, but...
Impressive, but does it actually equal understanding?
Okay.
That's what they're getting at.
So, I can find the artist's signature on a painting.
Right.
But that doesn't mean I understand the art itself.
Exactly. And that's the problem with a lot of current evaluations. This research proposes a new way to look at it, focusing on an LLM's ability to extract meaning and structure from information, like sculpting.
Sculpting. Okay, now you're just messing with me. What do you mean sculpting?
Instead of just pulling out a needle of information, they need to chisel away the irrelevant parts to reveal a hidden structure, a masterpiece of understanding.
I'm intrigued, but I need a little more to go on. How do they actually test that?
So they designed 3 unique tasks for the LLMs, each one with a different kind of latent structure hidden within.
Latent structure.
Yeah, think of it like the underlying framework, the skeleton beneath the surface.
Gotcha.
So we've got latent list, multi-round co-reference resolution.
Multi-round what?
We'll get to that one.
Okay.
And my personal favorite, IDK.
IDK. I'm already scared.
It's not that scary, I promise.
All right, let's start with something a little more digestible. Latent list. What's the challenge there?
All right. Imagine you're giving an LLM a chunk of code.
Okay.
This code modifies a list of numbers, adding, removing, sorting, pretty straightforward.
Right, makes sense.
But here's the catch. Hidden within this code are useless commands. Distractions designed to trip up the LLM.
Oh, sneaky.
It has to differentiate between the important instructions and the irrelevant ones to figure out what the final list should look like.
So you can't just parrot back the code.
Nope.
It has to understand the task, ignore the fluff, and execute it step by step.
Exactly.
Like a chef sifting through a recipe with a few random ingredients tossed in.
I like that analogy.
All right, you tease this multi-round co-reference resolution thing.
Yeah.
Sounds complicated.
A little bit. Imagine a really long, messy conversation.
Okay.
And in this conversation, someone's asking the LLM to write different things.
Okay.
Poems about penguins.
Poems about penguins, all right.
Essays on basketball. You get the idea.
Yeah, a real grab bag of topics.
Exactly. The LLM then has to identify a specific piece of writing from that jumbled conversation.
Oh, man.
Even if there are similar requests mixed in.
That's like trying to find that one version of a presentation in my downloads folder.
Right. Talk about information overload.
All right. So what about IDK? You said it was your favorite.
Ah, yes. IDK. It's beautiful in its simplicity.
Okay.
They ask the LLM questions that it cannot possibly answer based on the information it's been given.
Okay.
The key here is not finding the right answer, but recognizing that there isn't one.
So they're testing the LLM's self-awareness.
Exactly.
Wow. Whether it knows what it doesn't know, that's a whole other level of cognitive ability. So did they find any LLMs who are up to the task? Can they really sculpt knowledge from data?
Well, the results were, let's just say, a mixed bag.
So last we left off, these researchers were basically throwing more information at these LLMs than a fire hose.
It was quite the deluge of data.
And expecting them to create something meaningful out of it. So like, where did things start to get tricky for these AI artists?
Well, the interesting thing is the LLMs didn't just completely crumble under the pressure. They showed a pretty consistent pattern, actually.
Oh.
After an initial dip in performance, as the amount of information increased.
Like they were overwhelmed at first.
Exactly. Most models either plateaued or their decline slowed down significantly.
So it's like they hit a ceiling, but they didn't completely fall apart.
Exactly.
Yeah.
And that's important because it suggests that it's not just about building bigger and bigger models.
Okay.
It's about finding smarter ways to train them to process and understand information.
It makes you think about those people who, they try to cram a semester's worth of knowledge into one night.
Right.
At some point, your brain's just like, no more.
Exactly. And this research suggests that there are similar constraints in how LLMs currently learn.
Okay. Interesting.
But it also revealed something else really intriguing.
Okay.
Different models had distinct strengths and weaknesses.
Oh, so not all LLMs are created equal.
Precisely.
So some are better at sculpting certain things than others?
It's a bit like that, yes. For example, when it came to the multi-round co-reference resolution task, remember that messy conversation we talked about?
Yeah.
The Gemini family of models consistently outperformed the competition.
Really?
Yeah.
So the Gemini models were like the star pupils when it came to following a complex conversation, remembering who said what and in what order.
Exactly. They excelled at tracking the flow of information, even in a chaotic environment.
It's like those friends, right?
Yeah.
Who can walk into a party, chat with a dozen people about a million things, and then recount the whole evening in perfect detail.
Right.
Some LLMs are social butterflies.
That's a good way to put it.
All right, what about that latent list task, the one where they had to ignore all the useless code? Were there any standouts there?
You know, the GPT models, particularly GPT-4, really shone in that arena.
Interesting.
They excelled at parsing and executing instructions even when faced with those distractions.
Interesting. So even though GPT-4 might be prone to seeing secret codes where there are none, it's still a powerhouse when it comes to, like, processing complex instructions.
Exactly.
A quirky genius, I guess.
You could say that. And it highlights how these different models might be using completely different cognitive approaches to tackling these tasks.
It's like saying some LLMs are like master chefs,
Yeah.
Following a recipe to the letter, while others are culinary artists, experimenting with flavors to create something new. But what about those IDK tasks, the ones that tested their self-awareness?
Right.
Any surprises there?
Well, as we discussed, GPT-4 had its moments, thinking those random letters were secret codes.
Right.
Interestingly, though, the Claude models, particularly Claude 3.5 Sonnet, consistently performed best on those IDK tasks.
Really?
Yeah.
So Claude 3.5 Sonnet was the most honest student in the class, like admitting when it didn't know the answer.
Exactly.
No guessing penalty for them.
Right. And that suggests a higher level of self-awareness, which, as we've been saying, is a crucial aspect of true intelligence.
Absolutely. This is all so fascinating, but it begs the question. Why are some models better at certain tasks than others? I mean, is it the way they're trained, the data they're fed, something else entirely?
It's likely a combination of factors. The model's architecture, the data it's trained on, the specific algorithms used to kind of fine-tune its performance.
So it's like saying someone's intelligence isn't just about how big their brain is, but how they use it, the experiences they've had, the connections they've made.
Precisely. And just like human intelligence, we're still figuring out the best way to assess an LLM's full capabilities.
Yeah, the Michelangelo framework definitely offers a promising new approach. It's like we're moving beyond, simple memorization and towards true understanding.
Right. It's about revealing the sculptor within these AI systems, their ability to shape meaning from the raw material of information.
Wow.
But we're still in the early stages of understanding how to fully unlock their potential.
This is reminding me of that GPT-4 code breaker quirk.
Right.
It's like it has this innate desire to find patterns and make sense of the world, even when those patterns don't actually exist. It almost makes you wonder. It almost makes you wonder if maybe we're limiting these LLMs with our human ideas of what it means to understand something.
Oh, interesting.
What if their way of processing information is just so different from ours that, we're not even asking the right questions yet?
That's a fascinating thought. We might just be scratching the surface of what these models are capable of.
Right.
It's like trying to understand the ocean by only studying the waves on the shore.
Okay.
There's a whole uncharted depth waiting to be explored.
Now I'm getting excited. We've gone from sculpting metaphors to uncharted ocean depths. But, okay, if we're just starting to understand these LLMs, what are the next steps here? How do we move beyond these, simple benchmarks and truly unlock their potential?
Well, it's a multifaceted challenge. We need to explore new training methods, ones that go beyond rote memorization and focus on developing a deeper understanding of context, of the relationships between different pieces of information. Imagine teaching an LLM not just to read a dictionary, but to understand the nuances of language, the way words interact to create meaning.
So it's not just about the quantity of data, but the quality of understanding.
Precisely.
Okay.
And that requires developing more sophisticated evaluation tools, tools like this Michelangelo framework.
Yeah.
That can accurately assess an LLM's ability to reason, to make connections, to extract meaning from all the chaos of data.
Michelangelo does feel like a big step in the right direction, at least. It's like we're giving researchers a more powerful chisel, a way to sculpt more meaningful insights from these AI models.
It's a collaborative effort, really.
Yeah.
Bringing together researchers from computer science, linguistics, psychology, all working together to kind of unravel the mysteries of how these LLMs think.
And as we unlock those mysteries, who knows what we might find, right? New scientific discoveries, groundbreaking technologies, maybe even new forms of art and literature. I, for one, am excited to see what the future holds for these LLMs.
As am I. It's truly a groundbreaking field with the potential to reshape our world in some really profound ways.
Well, there you have it, folks. We've journeyed deep into the world of LLMs.
We have.
Explored some cutting-edge research, uncovered some truly mind-blowing insights.
It's been quite the journey.
We've learned that LLMs aren't just, sophisticated parrots mimicking human intelligence.
Right.
They're capable of learning, reasoning, and even surprising us with their unique approaches to problem solving.
It's an exciting time to be paying attention to all this.
It really is. It's
Yeah.
been a fascinating deep dive. I hope you'll join us next time as we explore another corner of the ever-evolving world of knowledge.
Mm.
Until then, keep those minds curious. Ever feel like, I don't know, you need a dictionary just to understand the AI hype?
Yeah.
It's like composing symphonies 1 minute, predicting the stock market the next.
Right.
How do we really know what these AI models actually, understand?
Mm-hmm.
That's what we're diving into today.
Yeah. Trying to separate, the hype from the actual intelligence.
Exactly. Because intelligence in an AI, it's not like, measuring how fast a car goes.
Right. It's way more, nuanced than that.
So much more complex. It's like, okay, my phone can beat me at chess.
Sure.
Does that make it smarter? I don't know.
Right.
But this is where things get really cool. We're taking a deep dive into a research paper, just came out of Google DeepMind and Google Research, titled Michelangelo, Long Context Evaluations Beyond Haystacks via Latent Structure Queries.
Okay.
Now I know, right? Title sounds like a mouthful, but just focus on Michelangelo for now.
Okay.
Basically, these researchers, they created an AI IQ test.
Yeah, well, I mean, it's more like they designed a series of challenges to specifically assess how well large language models can, how well they really grasp complex information.
So not just finding keywords,
Right.
but actually getting it.
Precisely. A lot of current tests are like that needle in a haystack game.
Okay.
You hide a fact in a pile of text and see if the AI can just pick it out.
Okay, so one of those online quizzes where it's spot the word, like a word search.
Exactly.
Found it.
But does that mean the AI understands what an apple is? How it grows,
Right, or how delicious it is in a pie.
Yeah. The Michelangelo research wants to go way beyond that.
Okay.
They even make this this comparison to Michelangelo and how he describes sculpting. He said that the sculpture is already complete within the marble block. I just have to chisel away the superfluous material.
Wow.
Yeah.
So they're saying the real measure of AI, it's not just spitting back facts. It's about revealing the hidden masterpiece within the data.
Yeah.
That's pretty poetic.
It really is.
So how do they actually test for that? How do you build an AI IQ test?
So they call their framework latent structure queries, LSQ for short.
Okay.
And instead of simple search and find tasks, they designed 3 really clever puzzles to challenge these AI models.
Ooh, puzzle time. Okay, hit me with challenge number 1.
So the first test is called latent list. Imagine you give the AI a set of code instructions that are modifying a list, add a number here, sort it there.
Okay.
Sounds simple enough.
Sure. If you're an AI that's made to handle lists.
Yeah, exactly. But here's the twist. They throw in a bunch of completely irrelevant code just to kind of mess with it.
Okay.
The challenge is, can the AI track the changes in the list amidst all the other distractions and then answer questions about, the final result?
So it's like trying to solve a puzzle while someone's shuffling all the pieces around you. That's kind of devious. All right, what's next on this AI obstacle course?
Okay, so challenge number 2 is called multi-round co-reference resolution. MRCR.
Okay, I was about to say, I'm going to need that dictionary again.
Yeah, it's a mouthful. But the idea is actually pretty simple. Imagine you're talking to the AI, in a chat, and you ask it to write you a poem, maybe about a cat. And then later, you ask for a poem about a dog.
Okay.
Can the AI keep those 2 separate, even though they were both requests for poems? And then can it go back and find the cat poem if you ask for it again?
So it's testing if the AI is really paying attention to the details and the order.
Exactly.
Okay, that's something I struggle with sometimes. Okay, 2 down, 1 to go. What is the final challenge in this AI decathlon?
All right, so the last test is perhaps the most intriguing. They call it IDK.
IDK.
Yeah.
I don't know.
Wait, they're testing the AI's ability to admit when it doesn't know something?
Yeah.
That's surprisingly human.
Bro.
I like it. This one's all about recognizing the limits of your knowledge. They bombard the AI with tons of text, some of it relevant, some of it total gibberish, and then they ask a question. And sometimes the answer is just not in there. So can the AI confidently say, I don't know, or will it try to, make something up based on what's around it?
Okay, that's tough. That's something we struggle with too, right?
Yeah.
It's so tempting to just fill in the blanks even when you have no idea.
Exactly.
Oh, man. I'm dying to know, how did the AI models do? Who aced these tests?
It's like, imagine the AI Olympics.
Okay.
Different models, they excelled in different events. Like there wasn't one that was just like the ultimate champion across the board,
Interesting.
which I think is actually like a good thing. It shows how complex this idea of like AI intelligence really is.
Okay, so no perfect AI students just yet, but give me the rundown. Like, who took home the gold in each event?
Okay, so let's start with the Gemini models. They absolutely crushed the MRCR, that conversational one, with the poems and the essays.
Right, right.
Remember how we were talking about how the AI needed to keep track of the different requests?
Yeah, yeah.
Gemini was amazing at that, like remembering who said what, in what order, even as the conversations got like longer and more complex.
So if I'm looking for an AI to like co-write my next screenplay, Gemini's the one to call.
They certainly seem to have a knack for like dialogue and context.
Yeah.
Now, GPT, on the other hand, they were like the code whisperers of the bunch. They aced that latent list challenge.
Okay.
The one with the instructions kind of hidden in all that other code, the gibberish.
Yeah, yeah, like they had like X-ray vision or something.
Yeah, like they were noticeably better at keeping track of all the changes to the list. It's almost like they have a deeper understanding of the logical steps involved. And this is where it gets interesting. GPT really struggled with I don't know.
Really? So the code whiz can't admit when it doesn't know something. You're telling me, like, they would try to find an answer, even in the random text.
It's true, which is, I don't know, it's kind of endearing in a way. They were so determined to find the patterns, even when there weren't any.
Wow.
They would, like, see a puzzle where there was just randomness, which, honestly, is that not human? Right? Like, we do the same thing sometimes. We try to force meaning onto chaos.
Oh, all the time. I can't tell you how many times I've tried to, like, find a pattern in a random string of numbers, and I'm like, there's got to be something here.
Yeah.
So, okay, so if GPT is, like, the overthinker, who's, like, the most self-aware?
Well, the Claude models were generally pretty solid across the board, but one variant, the Claude 3.5 Sonnet model, really stood out on the IDK.
Okay.
They were the least likely to hallucinate patterns in the random text and just like consistently knew when to say, I don't know.
Wow, talk about a valuable skill. In a world with just, like, information overload and misinformation, knowing what you don't know is huge.
Yeah.
But this all begs the question, like, why does this even matter? It's super interesting to see how these AI models think, but, like, how does it affect us out here in the real world?
Yeah, I mean, that's the key question, right? And the answer is, it matters a lot. You see, understanding these strengths and weaknesses, these, like, quirks of AI intelligence, it's crucial for building better AI, safer AI, more reliable AI going forward. Think of it like this. Like if you were building a house,
Okay.
you wouldn't just use any material, right?
Right.
You need to understand like the properties of each one,
Okay.
the strength of the steel, how much insulation the wood provides, how concrete's going to react to temperature changes.
Okay, I'm following. So you're saying building AI is kind of like being a house.
Exactly. The AI models are building blocks. And just like those materials, each one has its own like strengths and weaknesses. Some are great with language, some are logic whizzies. Others are more cautious, more self-aware. If we want to build really like strong and reliable AI systems, we need to understand those differences.
Totally. It's like if I'm building that house and I know the wood's susceptible to termites,
right,
I'm going to treat it differently.
Exactly.
I'm not going to just like use it blindly and cross my fingers.
Exactly. We need to know the potential pitfalls, the biases, the limitations of each model so we can use them effectively, responsibly. And this Michelangelo research, it's exciting because it gives us a new set of tools to do that.
It's like we're getting this like behind the scenes look at AI intelligence.
Yeah.
It's not just what they can do,
right,
it's how they think.
Yeah, how they think. And that's huge for figuring out how to design even more sophisticated AI going forward.
Exactly. And here's something else to think about.
Yeah.
This research, it wasn't about training the AI to like perform better on these tests.
Right.
It was about figuring out their inherent capabilities, like their, I don't know, natural intelligence, so to speak.
Yeah.
It's like we're not trying to teach it to pass a test. We're trying to like figure out how it thinks naturally, what it's good and bad at, right from the start.
It's about understanding the raw potential of each model, not just what we can train it to do.
Which makes you wonder, if these tests are already telling us this much, what are we going to discover as AI gets even more, advanced? What new tests, what new challenges are we going to come up with to like really push the boundaries of AI intelligence? It's like We're explorers charting uncharted territory here.
Yeah, it is. And that's what's so exciting about being in this field. Every discovery brings new possibilities, new questions. It's a
Yeah.
journey of constant learning and, dare I say, wonder.
And the best part is, we're just getting started. Well, on that note, we'll wrap up our deep dive into the world of AI IQ tests. It's clear that the future of AI is just, full of potential, and thanks to research like this, we're getting closer and closer to understanding just how smart these machines might become. Thanks for joining us on this deep dive. We'll be back soon with another fascinating topic to explore, so until then, keep those human brains buzzing.
All right, so get this, today's deep dive. We're going deep into the world of large language models, but we're not just talking about their ability to find a needle in a haystack of data. We're talking about whether they can actually understand the haystack itself.
It's a fascinating question. It really is. Moving beyond simple information retrieval to actual comprehension.
Yeah.
Yeah, it's a big leap.
Right. And this research paper we're looking at today, Michelangelo, long context evaluations beyond haystacks via latent structure queries. It takes a really clever approach to try to figure that out.
It does. Instead of just asking LLMs to find facts, this research really challenges them with tasks that require deeper understanding of how different pieces of information relate to each other.
Okay, so less like finding a specific book in the library and more like understanding how all the books are organized and connected within the library's entire collection.
Exactly. It's about uncovering the hidden structure within a massive amount of information. Like Michelangelo, finding the sculpture within a block of marble.
Ooh, I like that. I like that analogy a lot. So how did they actually test this idea? They created something called latent structure queries. What does that even mean?
So essentially, they created these hidden patterns within data sets, and then they challenged these LLMs to uncover them.
Okay, so it's not about feeding them random information. It's about being very deliberate about how that information is structured.
Precisely. And to test this, they developed 3 unique tasks. The first one, called the Latent List Challenge, it involves giving the LLM a bunch of Python code instructions that manipulate a list, adding numbers, removing them, shuffling things around, that kind of stuff.
Like a digital recipe for numbers, essentially. So what's the catch? They don't actually want the LLM to spit out the code, do they?
You're catching on. They have to answer questions about the final state of that list, but they have to do it without actually running the code.
Oh, wow.
It's kind of like if I gave you a recipe, but instead of you actually baking it, you had to describe what the final dish would be just from reading the steps. Can they understand the logic and the outcome just by analyzing the code?
That's a pretty tough challenge, even for someone who knows how to code.
Yeah.
It reminds me of trying to mentally retrace my steps after a long day of errands. Like, did I actually pick up the dry cleaning or did I just think about it?
All right.
Did I actually buy milk?
And just like your errand example, the researchers made things even more difficult for the LLMs by adding in tons of irrelevant information just alongside those important code snippets. It's like hiding a tiny crucial message within a giant rambling novel.
So it's not just about understanding the steps, but doing so when there's a ton of noise and distractions.
Exactly. They wanted to see if the LLMs could stay focused on the task at hand and avoid getting bogged down by all the extra information. Think about how hard it is for us to concentrate when we're bombarded with notifications and emails. It's a similar concept.
It's true. It's true. It's, my attention span is lucky to survive a trip to the grocery store these days. Okay, so that's the latent list challenge, testing whether LLMs can understand the logic of code, even with distractions. What was the next test?
So the second challenge, this one ditches the code and dives into natural language. They call it multi-round co-reference resolution.
Okay, before you lose me with the jargon, can we break that down? What does that even mean in plain English?
Essentially, it tests whether an LLM can keep track of what's being discussed in a really long conversation. So imagine you're having a back and forth with an LLM, asking it to write various things, poems, riddles, emails, you name it. The researchers deliberately include very similar requests, like asking for 2 poems, both about penguins.
Okay, so far so good. How does this test the LLM's ability to understand long stretches of information?
So later in the conversation, they might ask the LLM to, say, reproduce the first poem about penguins. The LLM needs to not only remember both poems, but also correctly identify which one was actually being requested. It's like keeping track of multiple email threads simultaneously and making sure you're replying to the right one.
Gotcha. And I bet just like with the code challenge, they throw in a bunch of extra information to make it even harder, right?
You know it. They want to see if the LLM can keep all the threads straight, even when they're intertwined with a ton of other requests and information. It's testing their ability to remember, differentiate, and accurately reproduce information, all within a complex and evolving context.
So if an LLM can ace this challenge, it suggests they're not just parroting back information, but actually understanding the nuances of language and context.
Exactly. It's about connecting the dots and demonstrating a deeper level of comprehension.
Okay, so we've covered the challenges involving code and conversation. What was the third test?
This one is deceptively simple,
Yeah.
but incredibly insightful. They called it IDK, short for, I don't know.
I don't know. Okay, you've got my attention. Tell me more. How do you even test for that?
It's all about seeing if an LLM can recognize the limits of its own knowledge. So they feed the LLM some text, just like in the other tasks, but then they ask a question that cannot be answered based on the information provided.
So it's about testing whether an LLM will try to invent an answer or admit that it just doesn't know.
You got it. And this is actually a crucial aspect of intelligence because it prevents the spread of misinformation. And it encourages the LLM to stay within the bounds of what it actually knows.
That makes a lot of sense. We wouldn't want our LLMs to start, just making things up, would we?
Not unless they're writing us some amazing fictional stories. But in all seriousness, this ability to recognize the limits of one's knowledge, it's crucial for building trust and reliability in AI systems.
Absolutely. Okay, so we've got these three clever tests. The latent list, the multi-round co-reference resolution, and the deceptively simple but incredibly important IDK. Now, the big question is, how did the LLMs actually do?
Well, the results were kind of a mixed bag, It seems like long context understanding in these LLMs. It's kind of like athletic ability in humans.
Okay, I like where you're going with this. Explain it to me.
So just like some people are, great sprinters, while others excel at marathons, different LLMs had their own strengths and weaknesses when it came to handling these large amounts of information.
So no single LLM emerged as, like, the undisputed champion of long context understanding.
Exactly. Some LLMs, like certain GPT and Claude models, they did a decent job, up to a point. They could handle something like 128,000 tokens before their performance started to drop off.
128,000 tokens? That still sounds like a lot to me. How much information are we actually talking about here?
You're right. That is a significant amount of data. To put it into perspective, 128,000 tokens, that's roughly equivalent to the length of a short novel.
Okay, that makes more sense.
Yeah.
So they can handle a short novel's worth of information, but then they start to get tripped up. What about this Gemini model that you mentioned earlier? How did it do?
Well, the Gemini family of models, they really stole the show, especially when it came to those marathon-length contexts. We're talking up to 1 million token.
1 million. That's like feeding an LLM the entire Lord of the Rings series.
It's incredible. And what's really remarkable is that these Gemini models, they managed to stay relatively consistent in their performance, even with all of that information to process.
That's really impressive. What's their secret? Are they built differently than the other LLMs?
Well, that's what the researchers are trying to figure out. It suggests that Gemini might be using some innovative architectural approaches or training methods that make it particularly good at handling these really vast amounts of data. This could be, a game changer in the field.
So we might be seeing the emergence of a whole new generation of LLMs that can analyze and synthesize information on a scale we've never even thought possible before.
It's definitely a possibility. Imagine a future where AI can help us uncover hidden connections in things like historical records or scientific data or even entire libraries of literature. The potential is enormous.
This is why I love these deep dives. So many fascinating possibilities. But okay, before we get too carried away with the future, let's go back to the results of these tests. You mentioned earlier that there were some, surprising findings, particularly with GPT-4, something of that IDK challenge, right?
Ah, yes. GPT-4. Remember how we talked about the importance of LLMs knowing their limits, admitting when they don't have enough information to answer a question?
Right, like not trying to just make stuff up to sound smart.
Exactly. Well, GPT-4 took kind of an interesting approach to this.
Interesting in what way? Did it refuse to answer any of the IDK questions?
Well, it did answer some of them correctly. But in the cases where the researchers added in those random strings of letters as filler content, things got a little weird.
Okay, now you have to tell me more. Random strings of letters, what were they trying to do?
So remember, in the other tests, they used things like extra code or irrelevant conversation to kind of distract the LLMs. Well, in this case, they threw in these random sequences of letters, almost like a nonsensical code.
So what happened? Did GPT-4 just ignore them?
That's the thing, it didn't. Instead of saying, I don't know, GPT-4, it seemed to think it was solving a puzzle.
You're kidding. It was trying to find some hidden message in a jumble of random letters.
It seems that way.
Yeah.
And because it thought it had, cracked the code, it would confidently select one of the multiple choice answers.
Even though, by definition, there was no right answer, because the question was designed to be unanswerable.
Precisely. It's both hilarious and a little alarming, isn't it? Like, GPT-4 is so determined to find patterns and make sense of things that it sometimes invents them where they don't exist.
That's a good way to put it. I mean, we've all had moments where we've tried to, find meaning in something completely random, right?
Yeah.
But it does highlight a potential pitfall with these incredibly powerful AI systems. Just because they can find patterns doesn't mean those patterns are always meaningful.
You've hit the nail on the head. It's like that saying, when all you have is a hammer, everything looks like a nail. And GPT-4, with these incredible pattern recognition abilities, might sometimes see puzzles where there are none.
So what does this tell us about the current state of LLMs? What's the takeaway from all of this? So we've got these LLMs that are like these super-powered brains trying to make sense of the world, and sometimes they even, see patterns where none exist. What does this all mean for the future of AI? Where do we go from here?
It's a great question. And this research gives us some really important clues, I think. It highlights how we need to kind of shift our thinking about AI progress,
What do you mean?
Well, for a while now, we've been so focused on building bigger and bigger models, feeding them more and more data, seeing how many facts they can remember. But this research shows that true understanding, the kind that involves critical thinking and recognizing the limits of your own knowledge, well, that's a whole different ballgame.
So it's not just about how much information they can process, but how well they can actually think about it.
Exactly. It's like, think about the difference between just memorizing a textbook, rote memorization, versus actually understanding the concepts and being able to apply them in different situations.
Right.
It's a whole different skill set.
That makes a lot of sense. So how do we even begin to measure something as complex as understanding in AI?
That's the million-dollar question, right? This Michelangelo research, I think, is a great starting point. It shows how we can develop more sophisticated tests and metrics to really evaluate these LLMs. It's not enough to just ask, can you find this fact in this sea of text? We have to design challenges that force them to think critically, to make connections, and to recognize when they just don't have all the answers.
And that IDK test, as simple as it seems, it's a really clever way to do that. It's like a reality check for these LLMs, making sure they're not just trying to please us with answers they think we want to hear.
Exactly. We need AI that's honest about its limitations. AI that can say, you know what, I don't know, when it genuinely doesn't have the answer. That's how we build trust. And that's how we ensure these systems are used responsibly.
This has been a real eye-opener. It's like we're standing at the edge of this whole new world of possibilities with AI. But we need to make sure we're asking the right questions and developing the right tools to guide its development.
Couldn't agree more.
So for our listeners, for those who are just kind of starting to dive into the world of AI, what's the most important thing they should keep in mind?
I'd say approach it with a healthy dose of curiosity and maybe just a touch of skepticism. Don't be afraid to ask questions, challenge assumptions, and remember that even the most advanced AI is still a reflection of our own, human ingenuity, and yes, sometimes even our quirks.
Well said. And on that note, I think we'll wrap up this deep dive into the fascinating world of LLMs and their quest for true understanding. Thanks for joining us, and we'll see you next time for another exciting exploration of the world of information.
Hey, deep divers, ever wonder if AI truly gets all that info it processes, or if it's just a really good mimic?
Yeah.
Today, we're going to be going deep on this with a fresh research paper. It's called Michelangelo, Long Context Evaluations Beyond Haystacks via Latent Structure Queries.
Okay.
Yeah, it's a mouthful.
Right.
But trust me, the ideas are worth it.
Yeah.
We're basically trying to see if AI is just good at finding needles in haystacks,
Mm-hmm.
or if it can actually understand, the whole haystack, if you will.
Yeah. It's a great analogy. And what's so cool about this whole Michelangelo approach
Right?
is that
Right.
the researchers, they designed all these tests to see if AI can do more than just like spit back facts, right?
Yeah. Yeah.
They want to know, can AI actually connect the dots, like figuring out the shape hidden within like a block of marble?
Okay, so picture this. The first test is called Latent List. Imagine giving an AI a recipe, but instead of ingredients, it's lines of Python code.
Now, for those of you who don't speak Python, think of it like a set of very, very specific instructions.
Right, right.
And to make it even trickier, some of these instructions are totally useless, right? Like stirring the batter in one direction and then immediately back again. It doesn't do anything for the cake.
Right.
But it throws off the AI if it's just memorizing steps without understanding the goal.
Exactly. It's about understanding the process, not just the steps.
Right.
And get this. The study found that by adding these distracting instructions, some AI models' accuracy dropped by a whopping 20%. Talk about a cake fail.
Wow.
Yeah.
So it really shows you how, even with all this data crunching power, AI can still trip up when trying to follow a long line of reasoning. Makes you think twice about those AI will replace programmers headlines, huh?
Yeah, for sure.
Now, hold on, because the next test gets even wilder. It's called multi-round co-reference resolution, or MRCR.
Okay.
And it's all about following a conversation.
Imagine trying to grab a specific piece of info from a huge email chain with tons of replies and forwards.
Right.
Right.
Yeah.
So MRCR is testing if the AI can not only follow along, what you were saying with that long email chain, but then also pinpoint the specific detail that you're looking for.
Right.
It's kind of like...
Yeah, like finding that
one crucial email, buried under a mountain of reply-alls.
Absolutely. And here's where it gets really juicy. The researchers found some AI models actually got worse at this.
Oh, really?
As the conversations got longer.
Interesting.
Yeah, one model's accuracy dropped by almost 15%.
Wow.
With each additional round of conversation.
Wow. So it's like...
Yeah, they basically have a short attention span, which, not ideal for, say, summarizing a long meeting or navigating a complex negotiation or something like that.
Yeah, it's almost like... It's like trying to recount a movie plot based on like a few random clips that you saw, like on social media or something. You might get the gist, but you're going to miss a lot of like those crucial plot twists and character development.
The nuance.
Right, exactly. And that brings us to the final and arguably most mind-bending test, which is called IDK.
IDK.
Which stands for I don't know.
Okay.
Okay, so I'll admit, like, when I first heard about this, I was like, how do you even test for that?
Yeah.
Like, how do you test if an AI knows when it doesn't know something? But it's actually quite brilliant the way they did it.
Yeah.
They basically show the AI a bunch of information, and then they ask a question that's just impossible to answer based on what they've been given.
Okay.
It's like... showing someone like a beautifully set dinner table and then being like, so how many bathrooms are in this house?
Right, yeah.
Like the information just isn't there.
It's just not there.
And here's where it gets really, really interesting.
Yeah.
Is the AI models had like vastly different responses to this.
Oh, interesting.
Some of them just aced it.
Okay.
They were like, I don't know.
I don't know.
Which, let's be honest, is a skill even humans could use more of sometimes.
Right. 100%.
Right. Like just knowing your limits.
Knowing what you don't know.
But of course, not all the AI models were so self-aware.
Right.
Some of them, particularly those fancy GPT models,
Yeah.
they fell into what the researchers call hallucination.
Hallucination. Okay.
So basically, they try to force an answer.
Okay.
Even like making connections where there are none.
Oh, wow.
It's like, you know those conspiracy theory message boards where people like connect like random dots on a map?
Right, yeah.
And they're like, you see, this is proof of aliens.
It's all connected.
Right, except here, like the AI is generating the conspiracy itself, which I don't know about you, but I find that a little unnerving.
Yeah, isn't it?
It's a little unnerving to think about that these models, they can sound so confident.
Right.
But this IDK test shows that sometimes they're just really, really good at making stuff up.
Just making stuff up.
Right. Which kind of brings us to, like, I think a crucial question here.
Okay.
What does this all mean?
Yeah.
You know, we've got these Michelangelo tests. Some AIs are passing with flying colors. Some are failing miserably.
Right.
So what's the takeaway for someone who, isn't building the next super intelligence?
Right. Right.
Well, for me, it kind of highlights like how different AI is from actual like human intelligence, you know?
Yeah.
It seems like AI still has like a ways to go before we reach that true like artificial intelligence.
Yeah, it's more like,
Like, you know?
it's more like artificial specialization right now, I think.
Right, exactly.
You know, they can be
Yeah.
really good at specific tasks, but lacking that flexible kind of adaptable intelligence that we have.
Right. It's like
Yeah. As humans.
we might not be able to like process 1 million data points per second or whatever,
Right.
but we can like see the bigger picture, you know,
Mm.
like spot when something's off and apply that knowledge to a totally new situation.
Exactly. Exactly.
We don't just find patterns, we like understand them.
Precisely. And that's, I think, the significance of this whole Michelangelo framework. It's not just about, you know,
Yeah.
pushing the boundaries of what AI can do,
Right.
but it's also about understanding how it's doing it,
Right.
you know? Are these models genuinely learning and adapting?
Yeah.
Or are they just like incredibly sophisticated mimics?
It's like asking, are they thinking or are they just really good at faking it?
Yes, exactly. 100%, yeah.
So the next time you hear about some amazing new AI feat,
Right.
think of, you know, Michelangelo chipping away at the marble and ask yourself, is this AI actually like revealing a deeper understanding? Or is it just creating a really, really convincing illusion?
Yeah, that's a great way to put it.
Because that's the key,
Yeah.
right? Being like informed, critical thinkers about this technology and separating kind of the hype from the reality.
Absolutely.
And on that note, deep divers, until next time.
Yeah, great deep dive.
Keep questioning, keep exploring, and we'll see you on the next deep dive.